An Atwood's machine consists of two masses. M1 is 2.83 kilograms and M2 is 7.86 kilograms. When released from rest, what is the acceleration of the system? I kind of drew that out here so you guys could see. So this is M1 and this is M2. And since M2 is heavier than M1, the acceleration is going to be downwards for M2 and upwards or positive for M1. Negative acceleration for M2, positive acceleration for M1. So to start with, we know the sum of forces in the y direction is equal to the mass times the acceleration in the y direction. And the sum of forces in the y direction is also equal to normal force minus mass times gravity. And in this problem, the normal force is going to be the tension of the string, because our free body diagram will look like this. Tension mg. So substituting this problem, or this part of the equation in for this, we get T minus mg is equal to m-a-y. So now we have to solve for the tension, and we end up getting the tension is equal to the mass. I'm just going to use the m1 here. The mass, well, the first mass times acceleration in the y direction, which is positive because it's going up, plus the mass times the gravity. So this is the tension for the free body diagram in M1. M2 would be T equals M2 or M2A, and notice that this is negative because acceleration is in the downward direction, so it's going to be negative, which makes this whole side of the problem, the equation, negative. Add that over, that's a negative sign. M2A plus M2G is equal to the tension. And since both of the masses are connected to the same string, the tension will be equal. So that means these two equations will equal each other. We can write that out as M1A y plus M1 G is equal to negative M2A plus M2G. Now we're going to try and solve for acceleration. So we're going to get these two on the same side. M1A plus M2A equals M2G minus M1G. And now we can factor out the acceleration. We get acceleration times M1 plus M2 is equal to, factor out gravity, M2 minus M1 times gravity. Now we just have to divide this over to find the acceleration. Acceleration is equal to M2 minus M1 divided by M1 plus M2 times the gravity. So plugging in our values, we end up getting 7.86 kilograms minus 2.83 kilograms divided by 7.86 plus 2.83 kilograms times gravity in meters per second, which is 9.8 meters per second. And that will equal our acceleration. So typing that in, we end up getting gravity times 0.466 kilograms is equal to acceleration, so 9.8 times 0.5 gives us a value of 4.57 meters per second squared for acceleration. Hope this helps.